Okay, hi everybody. We're working with the rationals chapter here, and what we're doing is we're trying to determine the horizontal and vertical asymptotes of each of these. So this one right here, in order for me to figure out the vertical and horizontal asymptote, I am going to have to factor this first, okay? So my denominator is very easy. This will be x plus 3, x minus 3, because that's the difference of squares. I can see that right away, which suggests to me that I could have two vertical asymptotes at -3 and +3. But I don't quite know that yet. I don't know that until I factor the numerator. And in the numerator, I'm going to have, what is that? That's going to be here, -4 minus 3. Okay? Here I see that the x minus 3, those cancel. However, so this function here is going to be equivalent to x minus 4 over x plus 3. Now, however, they're not exactly equal, okay, because the original expression was undefined at x equal to +3. This one that I'm left with isn't. So to make them equal, I actually have to state that x can't equal +3. Now they're equal. And what I get from this, sorry, is that this restriction here that I canceled out, that becomes my point discontinuity. The one that I can't cancel out, this x plus 3 factor in the denominator, this is what's responsible for my vertical asymptote. It's what I might call a essential discontinuity. X, okay, equal to -3, that is my vertical asymptote because I can't get rid of that. Now when I compare the degrees, and I can do this right back up with the first question here, if I compare the degrees of the numerator denominator, I've got an x squared term over an x squared term. Honestly, it doesn't matter. When I'm talking about horizontal asymptotes, it doesn't matter what the rest of that is. This is approximately equal to just x squared over x squared. When x gets really, really big, those are the only two things that matter. And they cancel out really nicely to give me a horizontal asymptote of y equal to 1.